Jesoro, and today I am going to discuss a short introduction about water resource engineering. All of us are aware of the importance of water. We use it every single day. And I saw an article stating that a human being can survive for 3 weeks without food. But without water, human being can go for 3 to 4 days. Why? Because dehydration sets in. So, every people, even if they breathe continuously, they will go into shock and become vegetative. That's why water is the primary necessity. And without it, without water, all living beings, including us, humans, animals, plants, simply cannot survive without water. Going back to our topic, which is water resource engineering, it is defined as the quantitative study of the hydrologic cycle. What is hydrologic cycle? Hydrologic cycle, it is the distribution and circulation of water, linking the Earth's atmosphere, lands, and oceans. As you can see in this image, hydrologic cycle begins with the evaporation of water from the surface of the ocean. As moist air is lifted, it cools and water vapor condenses to form clouds. Moisture is transported around the globe until it returns to the surface as precipitation. Once the water reaches the ground, one of two processes may occur. First, some of the water may evaporate back into the atmosphere. Second, the water may penetrate the surface and become groundwater. Groundwater either seeps its way into the oceans, rivers, and streams, or is released back into the atmosphere through transpiration. The balance of water that remains on the Earth's surface is runoff, which empties into lakes, rivers, and streams and is carried back to the oceans where the cycle begins again. Since water resource engineering is an engineering deals with the science of hydrology, so it is an engineering design system that match water supply with water demands. And it is also a design system that utilize, control, and manage water. So what I mean is the engineer here is responsible to make sure that everybody who needs it has enough water when they need it. And also engineers make sure that the produced water from melted snow will not affect or will not damage the present infrastructure or property. Most of the time, engineers tend to ask questions when it comes on water resource engineering, like how much water is needed or how much water is available. So overall, the water resource engineering is the study or the act of controlling and making decisions of equipment, facilities, and techniques that are used to manage and preserve life's most abundant resource. In addition to this, it is for assessing and to determine how or what are the best ways to control the water as it pertains to water-related activities such as irrigation and water disposal. So for me, it is very hard work for an engineer, as well as it is very important because they make sure, as an engineer, they make sure that we are safe, that the water we use are safe for us, not just for us, but for all living beings, like the plants and animals as well.
Their nomadic lives and settled in their own made shelters instead. With this, they started making demands for a regular source of water. So, to satisfy this demand, they started digging for wells in their settled communities. And as the demand for water increased and tools were developed, wells were made deeper, and later, on as early as 2500 BCE, were lined with bricks. At around 700 BCE, the construction of canals, or the slightly sloping tunnels driven into hillsides that contained groundwater, originated in Persia. The water was conveyed from hillsides to the nearby towns or cities with the open channels through gravity. The use of canals became widespread throughout the region, where some are still in existence up until today. Among the most notable of ancient water conveyance systems are the aqueducts built between 312 BCE and 455 CE throughout the Roman Empire. A Roman aqueduct usually included a series of underground and above-ground channels. The water conveyed by these channels usually ended in public baths and fountains where people get their supply. During the 19th century, materials such as cast iron pipes with joints were used to be able to withstand the high pressures of running water. At around the same time, steam engine was first applied to water pumping stations, making it possible for almost all communities to have drinking water supplied directly to individual homes. In the 20th century, asbestos cement, ductile iron, reinforced concrete, and steel came into use as materials for water supply pipelines. Today, water resources engineering spans its scope from creating hydraulic structures such as irrigation dikes, dams, spillways, floodways, reservoir, to water management and treatment systems to ensure enough and safe water supplies.
Hi, my name is Lenard Grutas, and I am going to discuss what does civil engineers do, or their tasks as well. So I am going to discuss only two tasks a water resource engineer do. 1. Water resource engineers create new equipments and systems in which it will increase the effectivity and effectiveness of water treatment and aquatic resource management. Okay, so they create systems and equipments. So examples of that are like the dams and any other projects in which it is made and created by water resource engineers. But to that definition of the first task that the water resource engineer do, they must take first budgetary constraints to the government regulations and other factors into consideration when designing these systems. Okay, so it's not going to be that easy. It means they're not just going to create new designs that fast. They still need to ask permission to the government and to agencies that will allow them to design the systems they created and to be constructed to make water treatment more effective and efficient. Okay, so that's number one task of a water resource engineer. They create new equipment and system to increase effectiveness and efficiency of water treatment and aquatic resource management. The second task of water resource engineers is that they oversee the construction and implementation of these systems to ensure that they are properly assembled. So, these projects that water resource engineers have been created, they need to monitor the progress of their design. Okay, so we know that all engineers do the same thing, that they need to watch out to their designs, if how are they doing, if they're fine, if it's properly assembled, if it's made precisely, or it is done based from their instructions. But after completion, they may manage the maintenance of their system. So when the system is done, they are going to maintain the effectiveness of the system that they have created. So that's what civil water resource engineers.
And my topic is about where does the water resource engineer work? Based on my research, a water resource engineer spends most of their time in an office looking for data and designing new water resource management system. They are searching for some designs that they can use in their new project. They may also spend their time in a construction sites allowed to see the constructions of their design. Some of the water resource engineers choose to travel abroad to participate in a large engineering project. Most of the water resource engineers work full-time with putting more than 40 hours a week. This extra time of the water resource engineers allows them to properly oversee the projects and assure that everything is running smoothly.
May we now talk about the examples of water resource engineering projects in the Philippines. Water resource engineers ensure that citizens are provided with a continuous supply of clean, uncontaminated water for drinking, living, and recreational purposes. So here are some of the successful projects of water resource engineers in the Philippines. First is the Bulacan Bulk Water Supply. The Bulacan Bulk Water Supply aims to address the water supply requirements of municipalities in the province of Bulacan, thereby reducing groundwater extraction and use of deep wells which are being discouraged due to adverse environmental impact. The project intends to supply treated bulk water to water districts in Bulacan province through the construction, operation, and maintenance of facilities for abstraction, treatment, and conveyance of treated bulk water supply. Next is the pilot septage treatment facility at Maymart Market, Barangay Zamora, City of May Kawayan, Bulacan. The treatment facility was designed to treat 200 cubic meters of septage per day. This is to demonstrate the reduction of pollution loading in terms of biochemical oxygen demand along the Mekawayan River. It was conceptualized to address the 70% pollution load being contributed by households at the Mekawayan Marilao o Banda River system. Next is the Dumaguete City Septage Treatment Plant. Dumaguete Septage Treatment Plant was designed to process all of the septage generated by the LGU from both household and business establishments. Next one is the San Roque Dam. The San Roque Dam is a multi-purpose dam providing power generation, irrigation, flood control, and improvement of water quality. Those are just some of the examples of water resource engineering projects. Overall, water resource engineers are tasked to do underground wells, natural springs, dams, wastewater treatment, sewages, river controls, and other facilities that cater the flow of water.
What is the job demand for water resource engineers? The number of open positions for water resource engineers is projected to grow 20% in the next 10 years, which is faster than average. Infrastructures are constantly aging and requiring repair and rebuilding. Water resources is needed at all times, as you will need basic water treatment, sewage, and so on, but it is mostly tied to government projects of infrastructure. With the world population continuing to grow and become more urbanized, and the impacts of climate change becoming ever more apparent, leading to more variability in rainfall, higher evaporation, and greater risk from flooding and sea level rise. The pressure on our water sources has never been greater. Several countries around the world, both developed and developing, are suffering drought conditions, and those tasked with sourcing and supplying our water are having to think more innovatively and strategically. As more barriers and shortfalls occur across the world, population will search new sources such as rainwater harvesting, desalination of the sea, and reclamation of wastewater. Therefore, the demand for water resource engineer is potentially going.
What are the education requirements to be a water resource engineer? In this discussion, the process needed to begin a career as a water resource engineer will be tackled in a step-by-step process. First is to earn a bachelor's degree in civil engineering. Bachelor's students undertake a variety of courses in math, engineering, statistics, fluid dynamics, and architectural design. They learn through a variety of mediums including class lectures, internships or co-ops, and on-site fieldwork. The degree can be completed in approximately 4 years of full-time study. Second is to complete a civil engineering internship. Almost all programs mandate at least one semester or summer-long internship to satisfy degree requirements. Students use these experiences to apply theories they've studied in the classroom, learn practical skills, and gain insight on a particular area of the field. These opportunities serve students well for future employment, allowing them to network with other professionals, receive mentorship from an established civil engineer, and possibly leverage their experience into a job after graduation. Third is choosing a specialty or concentration. This is the part where you can choose the area of work that you want to specialize. To be properly licensed, there is again a number of steps or common requirements stated as follows. Attend an ABET accredited institution, undertake the fundamentals of engineering examination directly after completing a baccalaureate degree, become a civil engineering intern, also known as an engineer in training, complete a minimum number of professional hours, meet benchmarks along the way, and complete the principles and practices of engineering examination to become a CE professional. Fifth is to land an entry-level job.
Now you know what water resource engineers do, where they work, and what are the education requirements needed. Let me show you some kinds and examples of societies and professional organizations water resource engineers have. Water laws and regulations from the U.S. Environmental Protection Agency, or EPA. The EPA is a U.S. government agency that regulates environmental law to protect the country's natural resources and public health. Water resource engineers must be familiar with the country's laws and regulations surrounding water in order to build safe, legal systems that can benefit the public. American Academy of Water Resource Engineer, or AAWRE. American Academy of Water Resource Engineer is a non-profit dedicated to advancing the education and knowledge of ethical practices to water resource engineers. They provide a diplomate water resource engineer certification that helps water resource engineer gain specialized knowledge in the industry and increase their ability. The American Backflow Prevention Association. The American Backflow Prevention Association, or ABPA, is an organization whose members have common interest in protecting drinking water from contamination through cross-connections. ABPA is an organization dedicated to education and technical assistance. Through its network of regions and chapters, local needs and interests are supported with the resources of the national organization. ABPA is committed to advancing all aspects of backflow prevention for the continued protection of all water users.
Good day everyone, this is Vincent and Jarabo, and I will be discussing to you the examples of water resource engineering projects in the world. First, we have the Contra Dam. It is commonly known as the Versailles Dam in Ticino, Switzerland. Contra Dam is a slender concrete arch dam standing at a height of 220 meters with a crest land of 380 meters. Lago di Vihorno is a reservoir that was created and now impounded by the dam when it was constructed between 1961 to 1965. This reservoir has a maximum capacity of 105 million cubic meters of water and a surface area of 400 acres. Next is the Gordon Dam. It is located in southwest Tasmania in Australia. Gordon Dam is a double curvature concrete arch dam. One of the dam's amazing feature is that it is curved both in vertical and horizontal directions to resist large hydraulic pressures coming from the 12,359,040 megaliters of water in Lake Gordon, the largest lake in Australia. One out of 48 arc dams that have been built in Australia, Gordon Dam is one of the only 9 that is designed to be a double curving dam. Then, we have the Monticello Dam. This 93-meter concrete arc dam in California, USA, is one of the coolest dams in the world of its mesmerizing spillway called the Glory Hole. The spillway is an uncontrolled morning glory type with a tip diameter of 22 meters and sits within the perimeters of Lake Berryessa, the 7th largest man-made lake in California. It can drain 48,400 cubic feet per second of water during the lake's peak level that occurs when the lake rises to 4.7 meters above the spillway's lip. And another one, we have the Hoover Dam. Hoover Dam is one of the most iconic dams around the world, stretching between the American states of Nevada and Arizona. Originally called the Hoover Dam, this colossal structure stands at a height of 121.4 meters, with a base width of 200 meters, and a crescent width of 418 meters. It is a concrete gravity arc dam that was constructed with the purpose to control flood, provide